In this lecture, we are going to discuss the topic change to polar. In that, we have to convert our Cartesian coordinate system xy into the polar coordinate system r and theta. And for this, we know that there is a standard substitution. That is, we have to replace x by r cos theta, y by r sin theta, and dx dy by r dr d theta. To explain that topic, I am going to use one example, and the example is evaluate the double integral over a dx dy upon 1 plus x square plus y square its square, where a is one loop of Lemniscate x square plus y square its bracket square equals to x square minus y square. First of all, we are concentrating on our given area. That means we have given the equation of Lemniscate, that is x square plus y square its bracket square equals to x square minus y square. First of all, we are plotting this equation of Lemniscate on the graph, and if we plot, then the figure will be like that. So you can observe that figure. There are two loops. One is at the negative x-axis and one is at positive x-axis. But we have provided our area is only one loop of Lemniscate, and therefore we have to consider only one loop from that. So I am considering the loop which is present at positive x-axis. Also here there are two lines passing through origin. One is y equals to x and another is y equals to minus x. Therefore our region of integration is the shaded region. That means we have to find the double integral over this one loop. But before that, we have to convert our given Cartesian coordinate system into the polar coordinate system. So for this, I am starting from our given equation of Lemniscate. Therefore, changing to polar coordinates by putting x equals to r cos theta, y equals to r sin theta, and dx dy equals to r dr d theta. First of all, we are considering our equation of Lemniscate, that is x square plus y square its square equals to x square minus y square. Now in this next step, we are replacing x by r cos theta and y by r sin theta everywhere. So we will get r cos theta bracket square plus r sin theta bracket square and whole bracket square equals to r cos theta square minus r sin theta square. Now from the bracket we can take r square common. So in the bracket only cos square theta plus sin square theta is remain. Similarly at right hand side we can take r square common, then the remaining term in the bracket is cos square theta minus sin square theta. And we know that the value of cos square theta plus sin square theta is 1, and the value of cos square theta minus sin square theta is cos 2 theta. That are the standard formulas. So by using that formulas, we will get r square into 1 to bracket square will get r raised to 4 equals to r square as it is, and the value of this cos square theta minus sin square theta is cos 2 theta. So we got the equation r raised to 4 equals to r square into cos 2 theta. Therefore 1 r square we can get cancelled. So the next step will be r square equals to cos 2 theta, and in the next step we are taking a positive square root. So we will get r equals to square root of cos 2 theta. We are taking only positive square root because we are considering only one loop, and that we have mentioned here by considering only one loop. Therefore r equals to square root of cos 2 theta is the equation of Lemniscate in polar coordinates, that is r and theta. Now we are going to consider the next figure which is in the polar system. So here you can observe that your x-axis and y-axis. So at x-axis right hand side your theta is 0, at upper side on y-axis your theta is pi by 2. Similarly at negative axis your theta is pi, and at lower side of y-axis theta equals to 3 pi by 2. And these loops of Lemniscate I have plotted as it is, and the equation of this loop only is r equals to square root of cos 2 theta. Similarly this line is nothing but y equals to x. So by putting x equals to r cos theta and y equals to r sin theta, we can get the value of theta equals to pi by 4. Similar way, by putting x equals to r cos theta and y equals to r sin theta, equation of this line I can write as theta equals to minus pi by 4. Now our target is to find the double integral using the polar coordinates. And for this we have to find the limit of r and theta. And for this I have drawn one shaded strip, and this strip we can draw randomly. Therefore we can observe this strip is starting from this origin and ending at this curve of loop. That means our radius is starting from this origin and ending at this curve of loop. Therefore lower limit of this r is r equals to 0, and upper limit of r is nothing but r equals to square root of cos 2 theta. That means we can write the limit of r as r varies from r equals to 0 to r equals to square root of cos 2 theta. Now we can observe these loops which is belongs in between these two lines, that is theta equals to minus pi by 4 and theta equals to pi by 4. That means our loops is in between theta equals to minus pi by 4 to theta equals to pi by 4. That means the limit of theta is from theta equals to minus pi by 4 to pi by 4. That means we can write theta varies from theta equals to minus pi by 4 to theta equals to pi by 4. Now we got the limit of r and theta. So using that limits we can write our given double integral as the integration over a dx dy upon 1 plus x square plus y square its bracket square equals to the integral from constant limit theta equals to minus 5 by 2 plus 5 by 4 in the curly bracket. The another integral is from r equals to 0 to r equals to square root of cos 2 theta 1 upon 1 plus r cos theta, that is value of x, its bracket square, plus r sin theta, that is value of y, its square, whole bracket square, into the value of dx dy is nothing but r dr d theta. Now we can observe our whole Cartesian system into the whole polar coordinate system. Conversion is completed. Now first of all we are solving our inside integral. So for this, first of all we are simplifying this term, that is 1 plus r cos square theta plus r sin theta bracket square, its bracket square I can write it as r upon 1 plus r square bracket square. That means after taking r square common, only cos square theta plus sin square theta is remains, and the value of this is 1. Therefore only 1 plus r square theta only 1 plus r square is remains there, and its bracket square as it is. Now we have to find the integration of this with respect to r, but for this there is a no standard formula, and that is why I am using a substitution. So I am putting 1 plus r square equals to t. So we will get, by differentiating both side, 2r dr equals to dt, and we want the term r dr only, so I am taking its 2 at RHS side, so we will get the value of r dr is nothing but dt upon 2. Also we have to change the limit, that is if I put r equals to 0 in that equation, then we will get 1 plus 0 square equals to t, that is nothing but t equals to 1. Similarly if I put upper limit, that is r equals to square root of cos 2 theta, then we will get 1 plus square root of cos 2 theta its bracket square equals to t, and it can be written as t equals to 1 plus cos 2 theta, and the formula of 1 plus cos 2 theta is 2 cos square theta. And therefore using that all substitution I can write this inside integral as the integral from t equals to 1 to t equals to 2 cos square theta, that is lower limit and upper limit, okay, of 1 upon t square dt upon 2, the curly bracket complete, and the integration of this with respect to theta. In the next step we are taking this 1 by 2 to outside the integral, and the integration of this 1 upon t square with respect to t is nothing but minus 1 upon t, that we have find using that formula, that is integration of x raised to n dx is nothing but x raised to n plus 1 upon n plus 1. Now after taking integral we are putting upper limit and lower limit. So if I put upper limit, that is we have to replace t by 2 cos square theta, then we will get minus 1 upon 2 cos square theta minus lower limit, that is we have to put t equals to 1, therefore minus 1 upon 1. After simplifying this we will get minus sec square theta, that is nothing but 1 upon cos square theta upon 2 as it is, plus 1, that is minus minus plus. Now we have to take an integration of this term. We know the integration of sec square theta is nothing but tan theta minus 1 by 2 as it is, and the integration of 1, that means integration of constant, is theta. After taking the integral, we are putting upper limit and lower limit. So in the next step, we have to replace theta by pi by 4 firstly. So it will get minus 1 by 2 tan, instead of theta we are putting pi by 4. So tan pi by 4 plus pi by 4 minus, now we are putting lower limit, that is theta equals to minus pi by 4. So here minus 1 by 2 as it is, tan of minus pi by 4 minus pi by 4. And we know that the value of tan pi by 4 is 1. So minus 1 by 2 into 1, that is only minus 1 by 2, plus pi by 4 as it is, minus. Here tan is odd function, that means the value of tan of minus theta is minus tan theta. Therefore here tan of minus pi by 4 is nothing but minus tan of pi by 4, and this minus 1 by 2 will get plus 1 by 2 into tan pi by 4, and the value of tan pi by 4 is 1. Therefore only 1 by 2 is here, minus pi by 4, this as it is. And after calculating this, we will get pi by 4 minus of minus pi by 4, that is pi by 2. Similarly minus 1 by 2 minus 1 by 2, that is minus 1, this 1 by 2 as it is. And after multiplying this 1 by 2 to inside the bracket, we will get pi by 4 minus 1 by 2, and this will be our final answer. Thank you for watching the video.